Hey kiddos, I am back. Still struggling a little bit, but I'm back and I'm happy to be with you. Today we're going to be going over parallel and perpendicular lines. Let's get started with parallel lines. Parallel lines are lines that have the same exact slope and different y-intercepts. Let's look at these two examples. I see that they have the same exact slope, -7, and that their y-intercepts are different. Both lines have a slope of -7 and have different y-intercepts. So the key here is that in order to be parallel, they have to have the same exact slope, and their y-intercepts must be different. Now let's see about coinciding lines. Coinciding lines are lines that have the same slope and the same y-intercept. Here's an example. If we were to graph f of x equals -2x plus 1 and g of x equals -2x plus 1, the lines would be overlapping. They'd be right on top of each other. And the reason why is they have the same exact slope, and the same y-intercept. These are not parallel lines. They are the same line. Let's look at some examples. Example 1 asks, are y equals 3x minus 7 and y equals 3x plus 4 parallel? In order to be parallel, they must have the same slope and different y-intercepts. So we're looking to see, does it have the same slope? What are the slopes? Let's identify those. I see the slope here is 3 and the slope here is 3. So they do have the same slope. Do they have different y-intercepts? I see -7 and I see +4. So these are different. So in order to see if it is parallel, I'm checking, does it have the same slope? The answer is yes. Does it have different y-intercepts? The answer is yes. So these are parallel lines. Now we have example 2. Are y equals 1/2 of x plus 2 and y equals 1/2 of x plus 2 parallel? So remember, to be parallel, we need the same slope and different y-intercepts. The slope I see over here is 1/2, which is the same slope over here. So they do have the same slope. Now, do they have different y-intercepts? So this equation, the y-intercept is +2. And in this equation, it's also +2. This means they have the same y-intercept. So these are not going to be parallel. This is going to be a coinciding line. Let's look at the third example. Example 3 wants us to find the equation of a line that is parallel to y equals 2x plus 1 and it passes through the point 3, 4. Because it's parallel, that means it's going to have the same slope. So my line is going to have a slope of m equals 2. And I know its initial point is going to be 3, 4. Since they gave me a slope and a point, I can write an equation in point-slope form. So I'm given my slope, so I'll replace that with m. And I have my x and y values, my initial x and y values. So I can replace y1 and x1 with my x and y value. My first y value is 4, and my first x value is +3. So that's how you write an equation when you're given a point and the slope. Because when they told us that it was parallel, that meant it was going to have the same slope. For example 4, find the equation of a line that is parallel to y equals 3x minus 4 and it passes through the point 2, 1. Since it's parallel, that means it's going to have the same slope and a different y-intercept. So the slope is going to be 3, and it's going to cross through the initial point 2, 1. So since they gave me an initial point and they gave me the slope, I know I can write this in point-slope form. So we have y1, which is our initial y value. We have our slope, which is the m, and we have the x1, which is the initial x value. So y is going to stay the same, so I'll bring that down, minus the initial y value they gave us, which is 1, equals m, so the slope they gave us, which is 3, parentheses, x, which is going to stay the same, minus the initial x value they gave us, which is 2, and close parentheses. So this is an equation that is parallel to y equals 3x minus 4 because it has the same slope, and it passes through the point 2, 1. You'll notice that when we're writing a line in point slope form, we're not worried about the y-intercept. I can already assume it's a different y-intercept because they gave me this point. For example 5, this one I'm not going to be testing you on, but if it is parallel to the y-axis, that means it's a line that's going to be going straight up and down. Lines that go straight up and down are undefined. They have undefined slopes. And the equation is going to be written as x equals whatever that x value is, so -4. And that's because if it's on the x-axis, I know every single value on this line is going to be at x equals -4, which would be right here. So say this is the x-axis, this is -4, and the line is just going straight up and down. The y values may change, but the x value stays the same. So x is always going to be -4. And I got -4 from the x value right here. Go ahead and use the rest of this to practice, and then start perpendicular lines. Let's get started with perpendicular lines. Perpendicular lines are lines that have slopes that are opposite reciprocals. Remember, a reciprocal is an inverted fraction. For example, if I have 2 as a slope, remember 2 can be rewritten as 2 over 1. To get the reciprocal of that, I'm going to flip the numerator and the denominator. So in this case, the reciprocal of 2 is 1/2. The opposite reciprocal is when you change the sign. So since I originally had positive 2 over 1, the opposite reciprocal would be -1/2. So I take these two numbers, flip them, and I change the sign. That's an opposite reciprocal. So to get the opposite reciprocal, you're going to follow these 2 steps. The first one is to flip the numerator and denominator. Remember, in a fraction, the number on top is the numerator and the number on bottom is the denominator. So to flip the fraction, we're going to put the denominator, the bottom number, on top, and the numerator, the top number, on the bottom. Our second step is to change the sign. So a positive number would become a negative number, and a negative number would become a positive number. For example, the opposite reciprocal of 1/2 is, let's flip the fraction. 1/2 will become 2 over 1, which is the same thing as 2. And then we're going to change the sign. So this is a positive, it's now going to be a negative. So the opposite reciprocal of 1/2 is -2. In these instances, the y-intercept doesn't matter. They could be the same or different. An example of perpendicular lines is y equals 1/2 of x plus 2 and y equals -2x plus 2. Remember, they have to have opposite reciprocal slopes, and the y-intercepts don't matter. They could be any number. They could stay +2, or one of them could be +20. The y-intercepts do not matter. The only thing that matters with perpendicular lines is that their slopes are opposite reciprocals. Let's look at some examples. Remember, to be perpendicular, they must be reciprocals and they must have opposite signs, so positive and negative. So in this case, I see 3 and 1/3 are the slope. If I turn 3 into a fraction, it'd be 3 over 1. Because the numerator and the denominator are flipped, these are reciprocals. The other requirement is that they must have opposite positive and negative signs. So right here, this slope is positive and this slope is positive, meaning they do not have opposite positive and negative signs. So these are not perpendicular. For example 2, are y equals 1/8 of x plus 2 and y equals negative 8x plus 2 perpendicular? Remember, it must meet these two requirements. They must be reciprocals and they must have opposite positive and negative signs. So let's see. This slope is 1/8 and this slope is negative 8. As a fraction, this would be negative 8 over 1. So first, are they reciprocals? 1/8 and 8 over 1. These are reciprocals, so it meets that requirement. Do they have opposite positive and negative signs? This is positive and this one's negative, so it does. So because it meets those two requirements, these are perpendicular lines. Let's see example 3. Are y equals 2x plus 1 and y equals 2x minus 8 perpendicular? Remember, they must be reciprocals and they must have opposite positive and negative signs. Let's look at their slopes. So the first slope is 2. As a fraction, that would be 2 over 1. For the second one, it's the same. 2 would be 2 over 1. So let's look at our checklist. Are these reciprocals? Are the fractions flipped? I see 2 over 1 and 2 over 1. These are not flipped. So I already know this is not perpendicular. But let's see, do they have opposite positive and negative signs? No, they're both positive. So this meets neither requirement. So these are not perpendicular lines. But remember, since they have the same exact slope and different y-intercepts, these would be parallel. No, but they are parallel. Let's look at example 4. We're going to find the equation of a line that is perpendicular to y equals 4x plus 7 and passes through the point 3, 4. The slope of this equation is 4, and the point they gave us is 3, 4. Since we have the slope and the initial point, we're going to write this equation in point-slope form. Remember, that's y minus y1 equals m times x minus x1. To find our new slope, we're going to find the opposite reciprocal. So our current slope is 4. As a fraction, that would be 4 over 1. The reciprocal of that would be 1 over 4. But remember, it's opposite, so I have to change the sign. Right now it's positive, so I'm going to make it negative. So our new slope is negative 1 over 4. So now I'm just going to replace my values. So I have y, which is going to stay the same, minus our y1 value, which is 4, equals our new slope, which is negative 1/4. Bring down the parentheses, bring down the x, minus our x1 value, which is 3, and parentheses. So we have our new equation, which is perpendicular to the line y equals 4x plus 7. Let's look at example 5. We want to find the equation of a line that is perpendicular to y equals negative 1/5 of x minus 4 and passes through the point 1, 1. So again, we're writing in point-slope form. The original slope they gave us is negative 1/5. And the initial point they gave us was 1, 1. To find my new slope, I'm going to find the opposite reciprocal. So I'm going to flip the fraction, and then I'm going to change the sign from negative to positive. Positive 5 over 1 can just be rewritten as positive 5. So my new slope is 5, and now I can rewrite my equation. We have y minus, our y1 value is 1, equals our slope, which is positive 5. Bring down the parentheses, x minus our x value, which is 1, or our x1 value, which is 1, and end of parentheses. And we have our equation. For example 6, it wants us to find the equation of a line that is perpendicular to the y-axis. So if this is the y-axis, then a perpendicular line would look like this. Whenever we have straight horizontal lines, that means the slope is 0. So our equation is going to be y equals whatever the y value was, which in this case is -3. And remember, the reason why is because no matter where I am along the x-axis, the value on the y is always going to be -3. Go ahead and use the rest of this time to practice.